So we get the token, we get the file words. We can calculate token counts, and we can sort token counts by occurrence. This is after this step, we have finished the first step in like 50% of the natural language processing's pre-treatment, which is term frequency calculation. We now know the term frequency. The next step is to calculate document frequency correlation, which means the appearance of words, the correlation of different words showing up in different documents. In order to do that, we need to create two arrays, token from files 1 and token from file 2. Of course, because we will need to use this calculate token counts, we will also need to create the counts array, but here counts is not the key because we are not using term frequency here. But we do need to have a token frequency from each file, as well as the total tokens array. Total tokens array will contain every token that have show up, and tokens from each file will be just the tokens showing up in that file. Then we will create a two-dimensional array, which is correlation. Correlation array will contain all the document frequency of each word pair. Let's say four score. I think the first two words, 4 scores. 4 and scores shows up together in Gettysburg address, but probably not in the second inaugural address, right? So this is the one document correlation frequency. We need to create this correlation array, and its row length and the column length should be the same as the length of total token array. Then for each row and each column of the correlation array corresponding to the elements in the total tokens array, then we will create a method that calculate correlation. In order to calculate correlation, we need to go through the word pairs in the tokens array. How do we get the word pairs? So first of all, let's think what is a word pair, like 4 scores. 4 is one word, score is one word, and when they show up together in Gettysburg address, that's one word pair. Now, the third word in Gettysburg address is and. So 4 and and is also a word pair. So we need to basically go through all the words in Gettysburg address, compare it with a 4. Then after 4 is compared with all the words, we will go to scores and compare all the words with these scores. So you can see that that's a 2D nested array, nested loop. You go through all the words, compare it, associate it with all other words in Gettysburg address. And thus we form the word pair. Now there are questions. This is how do we get all word pairs from the token array. But then how do we make sure each pair is unique? Because if you think 4 scores is one pair, scores 4 is also a pair. There are two different ways of handling that. You can either start comparing only words that is after the word. Like for 4, you compare everything after 4. For score, you compare everything after score. You don't compare with the previous ones, like 4. Thus, 4 score will only show up once. But it's also possible that you want to check both 4 score and score 4. This is possibly useful in semantic analysis, where the order of words may mean different things. But anyway, for each pair, we need to find their corresponding index I and j in total tokens array, and increment the value of correlation I and j. Once we have that correlation ij, we will just use tokens from file 1 and file 2 to calculate for each files, and print out the first 10 by 10 values of the correlation array. So let's bring up lab, and we are going to create four arrays first. Then we will do calculate tokens for array 1 and for array for file 1 and file 2. So it will be tokens from oh, sorry. This tokens from file 1 counts from file 1. Tokens from file 2 and counts from file 2. And I think there's a file from words from file 1 and words from file 2. And there's an error. Local variable may not have been initialized. Oh, okay. So we need to do this same thing, same initialization too. Okay, so we calculate the total occurrence to populate these 4 arrays. Then we need to create a one-dimensional array. And the length and the column length should be the same as the length of the total tokens array. Equals to new int. And the size should be total tokens. Because we already said it's at 500, I'm just going to put 500 here. And followed by, now we have already done this part. We'll follow by creating this method. And if it looks a little bit clumsy, you can always move this down so that everything show up within the screen. In order to do this calculate the correlation, we will go through each word pairs in the token array. And then for each array increment, now let's convert this to Java language. So for each element in the token array, and then, for each, then for nested, for each element after that, in the token array, after the I array element. Let's say I, and this is J. And now here, find their corresponding I and J. You can see that there are actually performance enhancement that we can do, that we probably want to just find the corresponding index first instead of find this again and again. But because we only have a limited number of elements, we'll do this search every time, and we will increment corresponding index. This time it should not be called X. It should be called X and Y. All right, so let's do for loop. For, I think I actually missed total tokens. Yeah, total tokens is actually a bad name. It should be called total tokens in file. For int I equals to, oh, this is total tokens, but this is the tokens in file. So we should go through tokens file I equals to 0, I less than tokens.length, then I plus plus. And now for each element j in the token array, after element, there will be 4 into j equals to 0, equals to, it will start with from I plus 1, right? And it will be j less than tokens length and j plus plus. So now we are going through this loop and we will find their corresponding index x and y. In our case, because all the tokens in file 1 and file 2 already shows up in total tokens, so we don't need to worry about the possibility that we cannot find these two words. So let's do binary search. We'll do a binary search somewhere for loop, for, I think we have a binary search for array, for string. Is that string? Oh, this is int, but let's create a binary search for string and copy this over. So we have a, oops, what's going on? I think when I copy, I missed a curly brace. So let's copy this over and give it a proper indentation. But here it should be string. And when you do string search, you cannot use equal anymore, right? Oh, sorry. That was wrong. I shouldn't use binary search because there's no guarantee that the token array will, or total token array will be sorted. Actually, it won't, because total token is sorted by count, and there is no way this count will be alphabetic. So I think we need to do the sequential search. Chapter 7, I think we have a sequential search somewhere. Search array, which is not sorted, right? So let's copy this over. And like I said, we already guarantee that we will have the value. So let's assign proper indentation. And this time, again, let's change this to string. And one thing is string is not equal to anymore. It has to be equals. Make sure we use equals instead of equals to. And now we have the sequential search, which returns the element. So int x equals to sequential search for total tokens and tokens I. Into y equals to position of total y. And then correlation xy should increment. Now, as you can see, we are searching for this word in total tokens every time inside this loop. Oops, this is not y, but j. And this can be costly. Ideally, you should have the index mapped to this token string prior. So when you do, it will be a parallel array that includes like some kind of index in total tokens. Then when you match these two, you will directly go to the parallel array to get the subscript. But here, as we said, because this is a relatively small example, we will just run this way. But feel free to make adjustments to have a parallel array and assign these positions prior to going into this nested loop. So we already sorted. Now let's run this correlation. No, this should be, we should call this calculate the correlation first, followed by correlation and total token and token from file one. Let's run this token from file one first, and then we will do int j equals to 0, j less than this, and the j plus plus. Now we will do a system out dot print space plus correlation ij. Then after we print out this row, we will going to do a print line. Dot print line. Okay, let's do it. The sorting takes a while. Oops, I think there's a null pointer where we are doing sorting and oh, because equals. So I don't think we can, because this is a partially filled array. I don't think we can do that. We can do equals in this sequential search. So